So good evening, and thank you for joining us for the last of this session's Tech Talks. We've had a right old variety. This is our sixth talk, topped and tailed by Paul here. Paul did our very first talk, and he's doing the closing talk as well. My name's Angus Armstrong. I'm a member of the CED Executive Committee, and I organise the Tech Talks. As you know, all our talks are recorded, and they will be available on the CED's website and our YouTube channel sometime after the talk, if you want to catch up, or if you have somebody else who would like to know more about the subject. Paul's many things electrical, but solar panels is one of the things he's got some experience in, and that's quite apt to a number of the sort of areas that CED work in. I really quite like one of his little stories where he was, during COVID, he ended up locked down in Rwanda in 2020, and was able to work with the East African Power Company to install a solar network of supplying some 1,000 homes. But hopefully he's going to tell us a little bit more about this this evening. And so this evening's talk is called Solar Power for Remote Locations. I'm now going to hand over to Paul. So Paul, I'll first ask you if you can unmute yourself. I don't think I can do that.
Okay, can everybody hear me sufficiently loudly, clearly?
If anybody's got a problem hearing, so stick a hand up. Yeah, oh, we've got a thumbs up. That's good.
Oh, good, that's all right.
So now I'm going to pin Paul. Boom. So you're now it's over to you, Paul. You've got the screen to yourself.
Thank you. Yes, if Angus's pinning doesn't work for you, then go to View in the top right-hand corner. And view speaker as opposed to view gallery, and that should work. Not that you particularly need to see my face in great detail. As I mentioned to Angus earlier, this site that was to be fed by solar panels was 1,000 homes and quite a few shops amongst them, and also included a very small health post, not even a health centre. But the lab technician, who was one of only 2 staff, was delighted because his microscope could be used at any time of day or night, whereas previously it only worked when they had sunshine through the window, because he didn't realise that the bulb illuminating the sample in the microscope could have worked off a 12-volt battery, but wouldn't have been able to organise it. Anyway, he was delighted when it worked, and of course they use it, the microscope, a lot for malaria slide tests. So that was very gratifying, and that's how I find things when I'm out in that part of the world. It's wonderful being retired, being able to go out to these places. It's just a bit disconcerting when you find that you can't go home except with a repatriation flight that costs $3,300. And that's the reason I was stuck in Rwanda for, well, 5 months, and actually stayed another month to see this solar project through. So getting down to how it all works. Solar panels generate a direct current voltage, as one would have in a battery, but it's a variable voltage depending on the amount of sunlight. And this is very awkward to use because most machines need a fixed voltage because they're designed for that particular voltage. If you're in America, of course, it's 110 volts AC, and if you're in almost anywhere else, it's 230. So it's awkward that the voltage is variable. So it's necessary to have not only the solar panels, but also something that will accept this variable voltage and either feed it into a battery or synchronize with the mains and feed it into the mains. And that's the two types of solar installation that are around, is a standalone battery storage arrangement or a mains commutated arrangement where the inverter, charge controller, whatever you call it, has to follow the mains voltage in order to put the output of the solar panels into it in such a way that it actually exports the power or uses it on site. So generally for remote locations, we're talking about battery storage and then using it whenever it's needed. The problem, of course, with solar is that it doesn't generate much power at night time, even if the movement is quite bright. And so there is the need for storage if it's for anything other than maybe a solar powered pump. I must say immediately that I have no experience of solar pumps. If anybody else has, I'd like to hear from them later on. That's the way it works, basically. If your inverter is connected to push power into the mains, then it needs not only to follow the voltage, but it also needs to switch off if the voltage is not within the right limits or the frequency is not within the right limits, because it means there's something wrong with the mains. And if the solar system continues to generate into the mains in some way, which it's not allowed to do, but if it were to try to do so, it could be dangerous. It would, if the mains isn't there to trigger it, it shouldn't work at all. But we have to make sure that it can't work, because in the event of mains failure, there could be people working on the network who might get electrocuted if there are generators feeding into it when they thought they'd isolated it. So that's one danger. And the other danger is that when the mains is reconnected, it's out of synchronism. And that's rather like changing gear in a manual car without using the clutch, and can do a lot of damage. So that's what are called mains commutated inverters. That's the sort of thing you would have, and many houses in the UK now have it, with solar panels on the roof, and they connect into the meter position, and you have to have a meter that doesn't think that export of power is because you're defeating the meter and winding it backwards, which of course is illegal, and the electricity authority would want to catch you. And so they need a system where the meter can register both import and export of power. So all these are what is necessary if you want to do that sort of thing, and normally the installer does it all for you. When it comes to remote places, you can use the same sort of system with a mains commutated installation. If there's a supply from a local grid that is sufficiently reliable to be worth connecting to, or if you've got other generators on site, maybe diesel generators, and they need a bit of help because the load on the site is growing. The only problem with that I discovered when CED actually put me in touch with a hospital in Bangladesh, and they have 3 standby generators, although they do operate separately on different parts of their network. But the question was, what would the generator do if the solar system was generating so much power the diesel generator was actually required to produce less than zero power, because there was so much coming out of the solar, because it was a sunny day. And we never really worked out what would happen in that situation. If anybody knows, I'd be interested to hear. And so we decided it was just safer not to use the solar system when it was on the generator, and only use it when it was on the local mains. So putting that sort of thing aside, the most common arrangement, and it can be with solar panels as small as the one that was shown on Angus's picture on a thatched roof. Very often people will have an old car battery and a charge controller. And those are the three elements that you need. So the solar panel, the charge converter, which is an inverter, and a battery. And then they can buy 12-volt light bulbs, which work off the battery at night. There are various things that need to be overcome with that sort of system. First thing is that panels are heavy. Now, if you've got a tiny little one like the one that was in that picture, that's probably going to be fine. But a full-size panel, typically 2 meters by a meter, can weigh 30 kilos. And if you decide to put up 50 of those on a roof, you need a structural engineer to make sure that the roof is actually strong enough to bear the weight, and also any additional loading due to wind. And depending what area you're in, I mean, it's unlikely that anywhere near the equator you're going to get any snow loading, but that is an issue in this country. Panels are heavy, and secondly, they are subject to theft. They're quite expensive, and so if people steal them, it's quite easy to resell them for a significant amount of money. But the trouble is, they need to be outside, and so the quandary is how to keep them safe from theft and yet exposed to the sun. And that's why people like to put them on roofs, because they're not so accessible. The other things you need to think about are at what angle to mount the solar panel. If you mount it at an angle to the light from the sun, then you're not going to get the full amount of irradiation that you could have if it followed the sun. Now, one of the systems I've experience of, which is in Rwanda, and it's with the same company that was involved in the 1,000 houses, East African Power. The main picture on their first page of their website used to be their solar farm, which had 30,000 solar panels, each 2 meters by a meter, and it generated 8.5 megawatts. And not only did it do this, but the panels were designed so that they were facing east in the mornings, and then would follow the sun until they were facing west in the evening. And then during the night, they go back to face east again, ready for the morning sun. Now, when you've got 30,000 panels, it's well worth doing that sort of thing. If you've only got a few panels, the cost of the mechanism and the device to follow the sun, and although it's really just a photocell at the bottom of a long tube, it's expensive and technically complicated, and so it may not be worth it. But certainly, it's not necessary, as I found the installation at Kagando Hospital, which is another place that CED have been involved, in Uganda, where the engineer who designed the scheme was very careful to make sure it was facing south at 30 degrees to horizontal, because that's the correct angle where he had learnt about solar power in Germany, and didn't go back to first principles and think, yes, but when you're near the equator, you want the solar panels to be flat, almost horizontal. If you make them completely horizontal, then if they have a rim around them, they may cause rainwater to pond, which is not a good idea, because you can get algae and other problems which can obscure the solar panel. But he just hadn't worked it out. He just assumed that 30 degrees was the right angle for solar panels anyway. So that's something that needs to be thought about, but it is necessary to think also about ponding, about drainage of rainwater, about how to minimize the accumulation of dust and sand and debris, which may depend on the prevailing wind. But mainly it needs some arrangement whereby somebody comes along every so often, preferably every couple of months, with a wet cloth and wipes the panel. And I've seen an enormous number of dirty panels in East Africa, where nobody has thought that, like a window, they need cleaning. Mind you, they're not very good at cleaning windows either, in a lot of places. The other problem, depending where they're mounted, and another project that CED is involved with is Nzara Hospital in South Sudan, spelled Nzara. Now, there, the solar panels have been mounted at an angle, and they've been mounted on a steel structure embedded in concrete in the ground. And the difficulty is that it's quite low, and so it's difficult to cut the grass that grows underneath it. And so all these things need to be thought about. How are you going to cut the grass? How are you going to kill the weeds? How are you going to prevent vermin from nesting below it? And how do you prevent it being scratched, maybe by footballs? Is it out of reach of vehicle collisions? And all these things need to be thought about before the panels are installed. So any standalone system needs a form of storage, and in terms of electricity, that's always batteries. Now, lead acid batteries, as normally used in cars in the past, they have a finite life. Sadly, most solar installers, most commercial ones, don't tell the potential user that their batteries do have a finite life. And in the case of lead acid batteries, as we all know with our car batteries, that can be 5, 6 or 7 years or so. And then you need new ones because the plates inside the batteries are regrown and eventually meet each other and cause short-circuited cells. And so batteries, lead acid batteries, do need to be replaced. Now, the next problem, of course, is that the culture in that part of the world does not include saving. There are two reasons for this. One is that very often people need the money for their immediate needs, and they don't have a surplus that they can save. And the other problem is inflation, which is even worse than in UK, which is why there are so many unfinished buildings in that part of the world. Because if anybody does have a large amount of money, it's better to invest in building a building, even if you only build one floor and leave the rebar sticking out of the flat roof. Because if you save the money and then try and build it, the materials will have gone up so much that you won't be able to build as much. So we now have lithium batteries, which are the sort of thing that you would have in a mobile phone or in a laptop or an electric car. These do last a lot longer. They are more expensive, but they're also less heavy. Lead, of course, is very heavy compared with other, even metals. But on the other hand, we all know about the batteries that people have had in their mobile phones, which have spontaneously caught fire. And the problems that that caused for, I think it was Samsung in particular. It therefore is difficult to organize for these batteries to be air freighted because the companies involved are nervous about carrying lithium batteries. They're very happy to carry lead acid ones as long as there's no acid in, because they're heavy and they can charge lots of money for it. But that is a problem with lithium batteries. So there's another consideration that needs to be borne in mind. And although a solar system is quite simple, it's there are all these extra complications around it. Things like, are there trees which are going to shade the solar panels? That was an issue at the Lamb Hospital in Bangladesh, where they, even though they mounted the panels on the roof was not that high and the trees were very big. And they need to think about when will the trees shade the solar panels? Does it matter? Where's the sun coming from, which direction, and think about it throughout the day. And all these things need to be taken into account. So I've mentioned some of the projects that I got involved with. As I say, I was talking to Angus before we started about the project to electrify 1,000 houses. This was in the extreme northeast of Rwanda, where there's a border crossing to Uganda and a wide river that separates Rwanda from Tanzania. And the Tanzanian side is a game reserve, so they don't have a crossing into Tanzania at that point. But it's one of the remote corners of Rwanda. And a few of the shops that had small panels, a charge controller and a battery, but nearly everybody had never had electricity before. So I think that's really it. But I would like it if people have either missed something or I've not explained it properly, you know, I'd be very happy to take any questions and cover it more. So it's do unmute yourself, and Roy seems to have his hand up. Roy, you're still muted, but if you want to ask a question, do. Otherwise, I notice other people also are unmuted.
Oh,
Eric.
hi you guys. I've just had 6 solar panels installed on the roof of our house, and actually we faced quite a lot of the problems that you've been talking about. First of all, the roof itself was in a terrible state, and when they came to survey it, basically said the roof's about 100 years old, the tiles are perished, they won't support the weight of the panels. So in the end, we actually had to get a new roof before we could put the panels on. So yeah, also the thing with trees, we've got a Christmas tree in the front garden, which is now about 20 foot tall, and that has shaded some of the front panels. But we didn't have a true south-facing roof, so we have half of our panels on the front of the house and half on the back. and the front ones catch it from early morning till sort of the afternoon, and then the back panels catch it from the sort of the afternoon to the late evening. So you know, it's the placement thing. Another problem we have is we have a lot of seagulls in our area, and so we had to get seagull netting put round the panels to stop the seagulls from nesting in the space between the panel and the roof. So yeah, lots of sort of problems.
Yes, thank you for that. The seagull nesting one is one I've seen in this country, but yeah, forgot to mention.
Yeah.
The angle of incidence of the sun is really just a question of geometry. You know, if you can keep the panel perpendicular to the direction of the sun, then you get the most power. If not, yeah, maybe is it worth having twice as many panels as you would normally need, just because you know you're facing east-west rather than north-south?
Well, the thing is, it was like we got this the panels themselves on a government grant scheme, and you have to take a minimum of 6 panels, 2.4 kilowatts. So that's why we have half on the front and half on the back to comply with the grant, basically.
And if presumably when we put a panel on a roof, we're going to put it at the angle of the roof. It's unlikely that we're going to create a framework that would make the panel less steeply inclined, or indeed more steeply inclined, if we're very far north. Yeah,
they just basically have to go with the roof that they've got and work out the best way.
I have seen steel frameworks in Africa because the roof is sloping, but they wanted the panel to be pretty well horizontal.
Yeah.
And it may be worth doing that. The other problem, of course, with that is the welding, because people don't use proper goggles in East Africa. They try to do welding using sunglasses.
Yeah.
And apart from the damage it does to their retinas, they don't get a good weld. And they can disguise that by grinding it flat, but really it's just a series of lumps of welds, and it's not as strong as it may look. So that's something to beware of in remote locations. You know, how good is the welding if you have some sort of framework? But the other thing with a framework, to give you the right angle, is does it then catch the wind? You know, you don't want the panels to blow away. And it can cause a pocket where, you know, the wind pressurizes on the back of the panel and it tends to lift off. So it does need to be very securely fixed to the roof.
Yeah, our panels, when they put them on steel box section rails underneath the panels, and then there's some kind of a special clip that fits the panels to the steel rails, basically to stop them from blowing away.
The rails that we used for the 1,000 houses and for the very big solar farm were actually aluminium or aluminium alloy. I wasn't involved in the specifications, I'm not sure which, but they were really good, because they're less likely to get, well, they don't rust. They do corrode, but not as much.
Paul, I wanted to take you back to the DC system, and you presumably for your 1,000 houses, each one was autonomous, and it would be a panel, a converter, and a 12-volt battery.
No, they weren't separate. They were grouped together. Okay. There were about, I think it was either 7 or 8 groups of houses, including one very big conurbation, which had to be split up into sections. but it's much more economic to have a distribution system like you would have in the UK. Of course, they had it overhead because that's a lot cheaper. And then every so often, or just in one village, there'd be one house that had 20 solar panels on it. Because for most people, the amount of power they're going to use is probably a couple of LED lights and a phone charger. So you're talking about an after diversity maximum demand of less than 10 watts. So you can have an awful lot of houses connected even to one large solar panel. And if you've got an array of maybe 20 or 30 on a structure, and what they did, in order not to have to buy land, they built a structure and chose one particular house and arranged with that house that in exchange for free electricity, they would build the structure over the house. Unfortunately, when I queried the strength of the structure, we fortunately had a structural engineer within East African Power who analysed it on his computer and worked out that actually we'd get just over half of the panels up onto the roof. And with two men working up there to fit it, that would be the point at which it would collapse onto a roof which would be corrugated iron mounted on tree trunks, resting on a building made of mud brick and mud mortar, which was not very clever. So we had to redesign it for them and charge them extra. I don't know whether they made any profit, but the problem was that the project was financed by GIZ, which is the German national aid organization, a bit like DIFI. And they built into the contract some really quite severe penalties for failure to complete by the specified time, which was a few days after the end of lockdown. And even then, they were not allowed to travel from Uganda into Rwanda to do the job, which is why East African Power in Rwanda got the job to do it for them. And of course, that involved the redesign of the framework.
Jumping back to the 12-volt system, if you have got, I guess your 1,000 houses, it would be true there as well. But if you've got a standalone system, panel converter, 12-volt battery, if the battery reaches a point at which it's full, it's fully charged, what happens to the surplus power?
Well, you could open the switch such that the solar panel no longer connects to anything. And I don't have detailed knowledge of the charge controllers, but I think basically that's what they do. You know, when the 12-volt battery reaches 13 or 13.5 volts, that's enough. We're fully charged. Switch off.
And so if the solar panel is still facing the sun, it's still generating some power.
Yeah.
Does that not matter? Because if you've got a hydro system and there isn't a load on the system, then I think the thing tends to run away with itself. It's not a good situation. Does it not matter?
No, it doesn't matter with, I see what you're saying. It doesn't matter with solar, because as soon as you open circuit the circuit, it just doesn't generate any power. The voltage is there, but it doesn't generate anything.
Okay.
Yeah. I just wonder if Barbara wanted to ask anything before she has to go.
And if she does, she needs to unmute herself. She might.
Maybe she's already gone.
Yeah.
I know Edward has been involved in some of the same projects that I have, wondered if he got anything to add. So I'm sure I've forgotten something.
I haven't done that much on solar power. It's mainly been hydropower that I've been involved in.
Yeah.
But it's very interesting talk. And what was I going to say? I was thinking about how you kind of liaise with East Africa Power, how you got your partnership going with them, and how all that worked out, and what specific projects were.
Yeah. Well, it just so happened that I knew of a missionary in Rwanda who set up a company, and a chap he used as project manager for his first project, then set up on his own and created East African Power, which now has about 100 staff and has become quite big, and has just got permission for a 6 megawatt hydroelectric project in Rwanda, in addition to doing the maintenance work and any repairs that are needed for the biggest solar farm in East Africa, which is the one in Rwanda, that's 8.5 megawatts.
Oh, wow.
They have a website, but I don't think the website features the picture of that, or at least it's not on the front page of that 30,000 panels. But as I said, they are hinged so that they follow the sun, which is a nice idea.
Yeah, I'm on the website now, but it's just got a big picture of the countryside in Rwanda and a few kind of shots of different people.
Yeah.
So, but I'll have a delve through that at some point and look at all the projects I have on the go.
Yeah, it's not as big a company as the website suggests.
Mm-hmm.
I should say, just to warn you, but they're doing a good job, and when they get involved in the community, they do other things like setting up a library. They've set up in one place, which is the founder's wife was there as a volunteer in the school and realized that there was no library. And not only have they managed to get loads of books out there, but they've also arranged that the school has internet access, which is quite rare in remote places.
Yeah, that's very good of them, isn't it? Doing a bit of social engagement as they do the projects, rather than just kind of plonking down a big engineering project without thinking of the impact it's going to have. Yeah. Wow.
Yes, that is something they are really keen to do. And then you know, you've got to do what your wife tells you.
Sorry, Roy, go on. We haven't got any sound with you, Roy. It tells us your microphone's up, right?
Yeah, Angus, I've just noticed that Barbara's got a hand up. Can we let her speak first if she's got to go?
Yes, absolutely. Yes, she needs to unmute herself as well.
I've only just noticed it. I don't know how long it's been there.
No, I don't see that. Roy, we can't hear you, but you could type your question in the chat bit. Down the bottom of your screen, you've got a chat option. We can't hear you.
You're muted at the moment. If you manage to unmute, we might hear you. That's better.
Can anybody else hear him?
No.
No.
We cannot hear you, Roy. You're going to have to type your question in the chat facility. And while Roy is doing that, I was going to ask about the 1,000 houses project. Technically, to install it, how clever do you have to be? Do we need a Paul Darrall to install it?
No, because it was actually a very high-tech system. The batteries came in the control unit, and the software had to be downloaded into the control unit once it was on site and connected up.
Okay.
But we were in touch with the company who designed it, with WhatsApp voice calls. And we did have one problem, which was that they asked me to press the reset button. And there was a button marked reset, but it wasn't, it was a dummy button. It didn't actually do anything. Oh, no, press the reset button. And I discovered that it was one of these little things where you have to have a very thin probe and push it into a hole, and inside it, there's a button that needs to be pressed. But it certainly wasn't obvious to me. Perhaps I'm a bit thick, I don't know. But they got a bit frustrated at that. But that was a system called Zola, Z-O-L-A, which is a clever way of saying solar without saying solar, but it sounds like it. And that was lithium batteries, at which, yeah. Oh, now, yeah, Roy's saying, what ongoing maintenance is there apart from cleaning? Cleaning is the most regular requirement.
Yeah.
Preventing vegetation from overtaking it and covering it is another. And then, depending on the type of batteries, replacing the batteries. Now, I'm not sure that we yet know how long lithium batteries last, but I think it's something like 15 years is what people expect at the moment. But it's a very new technology, and because of that, it may well be that there's, there are still improvements to come. As with any technology, when it's in its infancy, it's not as good as it ends up being later on. Following the incidents with lithium batteries catching fire in phones in people's pockets, which was nasty, I did see a documentary which showed research at a university where they had a polymeric separator between the positive and negative in the lithium battery. And you could actually cut the battery with a pair of scissors. It was only quite thin, while it was alive and while it was providing power, and it didn't interrupt the power. And I thought that was very clever. But I don't think that's yet commercially available.
Any idea how the cost of lithium compares with lead acid? If we're going to spend £100 on lead acid, how much should you spend for the equivalent in lithium?
I don't have that first-hand knowledge because I don't seem to get involved in the money aspects of these projects. Fortunately, which is rather nice as an engineer, not to have to worry about these things. Generally the project is already there and they just need somebody to make it work, as was the case at Chagando Hospital, where they had all these panels at 30 degrees that should have been flat. Yeah, and I think the other thing is that actually it's changing. The cost of panels has reduced quite considerably in the last few years, and I reckon the cost of lithium batteries will go up and down as well, and hopefully down, because that's the sort of thing that's being used in electric vehicles. And although not everybody is using them, I did see some electric vehicles in Rwanda. How many charging points they've got, I don't know. But I must say I would prefer not to have a 100% electric vehicle in that sort of situation. I'd much prefer to have a hybrid so I don't get stuck in the middle of nowhere with no charge in the battery. The other problem, I did once have an electric car in the 1970s, It was experimental, and they passed out, I think it was 50 of them, to the different electricity boards in the UK. And because I was the junior, I was given this car to drive. It cost a penny a mile for the electricity and 30p a mile to replace the batteries because they couldn't cope with the duty, which was mainly because they had to be charged so quickly. They got overcharged, which wasn't good for them. And then they got completely discharged flat the following day. And there was one occasion on which I was returning to the depot, and the car was going at about walking pace, which is very embarrassing when you're in a full-size, well, it wasn't quite full-size, it was like a 2+2 car. And so I gave up trying to drive it back to the depot, went into a side street, took the plug off the charger and connected it into a street lamp. I then sat there for 20 minutes, did some paperwork, and then was able to return to the depot, at which point some bright spark in the office said, "Oh, but that's stealing electricity." But then I'm working for, and the car belongs to, Northwest Electricity Board. So who's stealing from who? Yeah, it was all right. It was nationalised at the time.
All right. Ian Rankin, are you going to, now, Ian is building, almost finished building himself a house in Tanzania. Thinks he might move into it end of this month or next month. I'd be interested to know whether he's considering using solar on his project.
Yeah, we are planning to have solar panels, but it will be a bit, it's in between the single house with a 12-volt battery and the big sophisticated solutions. It will be totally off grid, but it will be giving a 240-volt supply to the lighting as an alternative to the municipal power. So it's just a little bit different from what we've been discussing this evening.
So will you have a battery in there?
We will have, yeah, and we're thinking we'll probably need about to draw 3 kilowatts of electricity roughly. So I'm hoping to supply about half of that from the battery and half from the solar panels, because that's not a continual draw. The average will be about a kilowatt a day. It's not an awful lot, a kilowatt hour a day. It's not an awful lot of electricity we use, but there will be peaks in that with fridges going on and washing machines and so on, possibly. And it may be that we just can't run big appliances through the system. I'm just not sure about that yet. Any advice would be most appreciated if Paul has ideas about that.
Dealing with the peaks and troughs, batteries can normally cope with that, but the thing that concerns me is that washing machines tend to spend a lot of power heating water. So if you can somehow avoid that and have a hot fill, that might work better. With the water being heated perhaps in some other way or heated at night, if there is mains. Generally, what I've found in East Africa is the power supply is more reliable at night than in the daytime, because people aren't fiddling about with it and working on it at night. But the other thing is motor starting. Now, modern motors tend not to take a large surge when they start up, but you need the inverter to be rated adequately for the largest load that you're ever going to have. Otherwise, it's going to blow its fuse or otherwise complain, melt, or explode. So that's a major consideration, and you might have to have some restriction that only allows certain load to be used when others are not being used. or buy a very large inverter. And it might be economical to alternate the large loads. But you can go an awful long way with lights now that we've got LEDs these days, because the amount of power they use is absolutely tiny. Phone charging, no problem.
Yeah.
A large panel, say 2 meters by 1 meter, will probably generate 250, 300 watts. So that gives you an idea of how many panels you might need. But then if the inverter is big enough, or you decide to do an installation now with the possibility of a second one later, and split the load between two, that can allow you to experiment with a relatively small installation and see how much you really need. But people in that part of the world are very good at using very little electricity, only using it for what it essentially needs to be used on. And so, you know, avoid things like heating water, which is very power intensive. Cooking, you might want to go for a microwave rather than a hot plate, which means that it's much more efficient. The heat only goes into the food and only for a short time, whereas hot plates and, you know, boiling beans for hours uses an awful lot of power.
Ian, you might want to consider using a solar thermal system on your roof. We've got one, and it's a drop-through system, and basically it heats the water in the panels and then drops it into a 250-litre tank, which is insulated, and it heats the water up to between 40 and 60 degrees. And if we turn the taps on and the temperature is high, the water runs straight through. And if it's not high enough, then it drops into our boiler, and the boiler just brings up the additional bit of temperature. But you can make a system whereby you just heat it in the panels, drop it in a tank, and just let it be gravity fed.
Yeah, we've got that in the house we're in just now. It works, but not in a cloudy day, sadly. And we don't have the boiler, although there is opportunity just to heat it electrically, which we're not doing. But yeah, I mean, these systems are quite common in Tanzania now.
Yeah. And also, are you going to put up rainwater gutters to catch the water?
Yes.
Have you heard of a guy called Robert Murray Smith?
No.
But basically, he's an electrical engineer, come sort of genius kind of guy, and he's just invented a rainwater generator that fits onto a standard downpipe, which can generate 12 volts. So maybe you might want to look into that, because it's all 3D printed.
Yeah, I looked at one of these a while ago, and I think you needed several tanks of water to kind of get one light going. I mean, are we talking about hydropower here from the rainwater? Basically?
Yeah, sort of, but he's got it down to a system whereby it's just sort of about a foot tall, and it fits in the downpipe. And there's two different types, one with a little turbine in it and one with a sort of a paddle wheel, and it can generate 12 volts, and then you just bung that into your battery, basically.
That'd be all right in Scotland, where it's always raining.
Not true.
Tanzania,
Wall-to-wall sunshine this week in Scotland. I just want to defend my patch.
But in Tanzania, where they have dry seasons, that could mean that you don't get your phone charged.
Yes.
Yeah. I mean, hydroelectric is lovely because it works 24 hours a day.
Yeah.
And very often there's a surplus, especially at night.
I've spent the last 2 days walking on some mountains above the Great Glen, the sort of Loch Ness kind of area.
Very nice.
and they're in the process of building a pump storage scheme there, a 1,500 megawatt pump storage scheme.
Wow.
In the UK.
There is one already at Cruachan, quite a big one.
At where?
Cruachan.
Oh, Cruachan.
Cruachan.
There's a few of them, yeah, and there's Denoric in Wales,
Yeah.
and there's one at Foyers, and that runs into Loch Ness.
Is that the ones where they let the water come out during the day or something, and then pump it back up during the night or something?
That sort of idea.
Yeah,
it's like a big battery, but the nice thing about them is they open the floodgates and it will generate peak power in seconds.
Yes.
So when EastEnders finishes and everyone puts the kettle on, can deal. The whole idea is to deal with the peaks in demand.
Yeah. The thing is, do we actually in this country generate more electricity than we actually need? Because I had a friend who used to work for National Grid, and he was always saying, "Oh, this week we've paid £500,000 to some place in Wales to turn off the windmills and all of this kind of stuff." Are we actually getting to the point where everything is come down in voltage? Like 100 years ago, everything was 240 volts, and now everything, laptops are 15 volts and light bulbs are 12 volts. Are we sort of generating more than we actually need?
No, we're not. But in order to maintain security, when the largest generator trips out for some reason, you do need to have what's called spinning reserve. And so you need something that can take over and provide the power, because on an electricity network, you always have to provide exactly the power that is being taken. Now, to an extent, that is covered by the inertia of all the generators. And that's why the voltage and frequency vary as the load goes up and down. But nobody normally notices that. But no, it's nothing to do with all the different voltages. The National Grid is always providing 230 volts plus or minus a small percentage. I think it's varied over the years. It used to be plus or minus 6%, and then they had to cope with Europe that wanted 220 volts. So they said, all right, we'll compromise. We call it 230 plus or minus 10%. And that goes up to the same top value that we used to have when it was 240 plus or minus 6. And it just allows for lower voltages. But actually, nobody has been round and changed anything on the British network. And they still use the same equipment. Some of the transformers have been there for, since 1900.
Yeah. We've got one on the corner of our street which constantly trips out, and they're talking about replacing it.
Well, and in the meantime, when the power's off, flame, because if it's off for more than 18 hours, you're entitled to flame. I think it was 18, maybe 12 now.
Yeah.
Can I jump us back to systems? If I've got a solar battery, not sure what's the correct title. Is it a converter or battery? And then I want to use 240 volts. So I draw it off the battery again. So I need another bit of technology at the other end.
Well, you can buy an inverter, which would probably be designed for use with a car cigarette lighter if you go camping. Or you're in a caravan that has a car battery in it. To produce 240 volts for all those appliances that can't cope with anything else. And that doesn't have to be specifically a solar item at all.
No. Once we pass the battery, we're out with. So what do we call the bit that goes between the panel and the battery?
So it's either an inverter or a charge controller. Those are the two things I've heard of. But it needs to be specifically an inverter for a solar system. And the charge controller is also an inverter. It just tends to be rather smaller. And they will need to know how much power you want to produce from your solar panels, and what voltage the battery is. Because sometimes people use 12 volts, some bigger system will use 48 volts, or it can be any voltage that the maker decides to have it. But of course, it's more convenient if it's something like 12 volts, for which there are lots of appliances available.
Mm-hmm. And then what we call is it a converter that we would use from the battery to give us 230 AC?
So you can buy commercially, and nothing to do with solar,
yes,
an inverter which will use 12 volts to produce 230.
Yeah.
Okay.
So you can get them from Lidl's, cost about 25 quid, and you can clip them straight onto your 12-volt battery.
So that piece of kit is another inverter.
Yeah. I mean, it's basically bulldog clips which you put on the negative and the positive.
No, sorry. The piece of kit that we that does the job is called an inverter.
That's what I've got, a little tiny one.
They do make them with different power ratings,
but they're always called a converter. Sorry,
no,
an
inverter.
Inverter.
Mm-hmm. Okay, that's good. Yeah.
What it does is it takes the DC from the battery,
mm-hmm.
it makes it into alternating current by chopping it up.
Yes.
Then uses a transformer to change the voltage, and then produces the 230 volts AC.
Yeah.
Alternating current.
I suppose
the
simplest approach would be to have a 12-volt system, lighting or whatever.
Yes, and you can buy, well, you can certainly buy them abroad, 12-volt LED bulbs.
Yes, right.
The problem is if they look like the 230-volt bulbs,
mm-hmm.
apart from the very small writing on them.
Mm-hmm.
Because if you plug in a 12-volt bulb into a 230-volt system, it doesn't last long, like a few milliseconds.
Yeah. Okay.
Because they do come with the same bayonet fitting,
mm-hmm.
or the Continental Edison screw fitting.
Yes.
And exactly the same size type of lamp holders. There's nothing to prevent you putting the wrong bulb in. Of course, the other way around, it's just that the bulb doesn't seem to work.
Mm-hmm. If you were running, say you'd got a 12-volt car battery, and you had got an inverter on it to give you 230 volts AC,
yeah,
and you got it, it's fully charged. What sort of useful power could you get out of that? Say you were, I don't know, say you were running small tools, a drill or an angle grinder or something.
Right, it depends how big your battery is. A car battery is typically around 70 amp hours.
Okay, yes.
So that produces 70 amps for 1 hour, or
right.
1 amp for 70 hours.
Simple arithmetic in that case.
But, yeah, but the problem is that when you raise the voltage, you need that much more current at 12 volts. If you're producing 20 times as much, i.e. 240 volts, then if you want 1 amp at 240 volts, you've got to take 20 amps from the battery.
Right.
To get the same power, because it just volts times amps.
Yes.
And so if you run anything substantial of it, the battery won't last, or the battery will become depleted very quickly. Now, I understand that lead acid batteries, if they're being charged and discharged frequently, should not be fully discharged. You should stop when you get to 30 or 40% full,
mm-hmm.
and then it will cope. But quite what it does to the life of the battery is difficult to tell. But if you're just, thinking, well, and I don't know how long ago it was, it's years since my house went, the power went off. Yeah, my daughter, who's in her 30s now, was about 10, I think, when we last had a power cut, and it wasn't for very long because I called myself out to our substation to restore it from the other direction. And then got shouted at by a neighbour opposite who didn't know me and asked why I had switched it off. Of course, quite how I managed to switch off the power when I was at home at the time, and only realised it went off when the lights went out. But anyway, they couldn't believe that anybody had got there so quickly. They didn't know that I was available and was able to walk to my local substation, knowing that it had supplies from 2 different directions and that it could be swapped over and get my own substation back on supply. And that was very important because I'd been left at home with my daughter, who, while we'd been away, had a Sky dish installed and was desperate to watch some children's program. And no sooner we got it started than the power went off. So it was very important that I got it back on again quick. And I never claimed a call out.
You probably would have got fined if you had.
But I did ring the control room before I got the permission to swap it over. And they were quite pleased because it did wonders for their statistics. One of the quickest ever restorations. Yeah.
Well, I think we've probably done this one. It's actually been very good, and I feel I've got a better handle on what all's happening with all things solar. Removed some of the mystique, and if nobody's got any other questions, then well, I think we'll probably wrap it up there. Is everybody happy with that?
Yep.
Yeah. Well, thank you very much, Paul, for speaking with us again. It's been good. And as I said at the start, this is the last of our Tech Talks for this year, and we'll see whether or not we manage to put a program on for the coming year, coming season. So thank you everyone for attending.